Morning, everyone. We are Delivery Mate. Our group consists of Ziad, Rush, myself, Maria, and Megan. So currently there's no real cost-effective or environmentally sustainable way for packages to get delivered in a state. And given the current pandemic, people are leaving their house less. And so there is more of a need for delivery services such as UPS and FedEx and Amazon Prime and such like that. So to help with this problem of the more need, we wanted to create a platform that delivers packages while using already existing resources to make it environmentally friendly. And there are 115 million people who commute every day. And so we wanted to utilize them to deliver packages as well as provide an additional source of income for people.
Meg, you're muted.
I'm sorry. So before we started, we wanted to do some market research, and we focused on FedEx and USPS. And these prices were calculated using USPS standard small, medium, and large box sizes with a standard weight of 5 pounds. Also, these prices were calculated using addresses between Edison and New Brunswick, New Jersey. If you look a little closer, FedEx is heavily dependent on weight, while USPS is heavily dependent on size. But with Delivery Mate, that's not an issue, because we focus more on the distance traveled versus the size and weight of the package. This makes us perfect for short distance travel. I would like to note that our Delivery Mate estimations will vary based on mileage traveled, and we'll go into that in a few slides. Our main contribution is that we're minimizing wasted resources because our platform is powered by commuters who travel the same route every day. And now shippers no longer have to travel to and from the post office because anyone can ship a package from the comfort of their own home or business. And users can expect their package to be picked up the day after they're matched with a driver, which allow us to provide next day delivery and cost-effective pricing. So here's our pricing model. This is just a rough outline of our predicted pricing for packages based on distance. The equation up on top is the one that we derived to find these prices, and we developed this model to be competitive with other courier services. And if you look closer, as the distance increases, the base pay decreases. And to incentivize drivers to join our program and deliver packages, they will receive 50% of the total cost paid by the shipper.
So now we're going to talk about our scientific component, our optimization model. Delivery Mate's algorithm solves an unbalanced assignment problem. So we're looking to minimize our objective function, which is the total deviation in minutes for each driver, plus the total number of drivers. We have two constraints. Each package must be transported by a single driver, and each driver cannot transport more than 2 packages. This figure on the right shows just how an unbalanced assignment problem kind of works. We have our packages on the left, and our drivers on the right. We have our optimal pairings, which are our gray arrows. Those are pairings that are good for our objective function. They minimize our objective function. And then we have our feasible pairings. Pairings that work, but aren't necessarily the best for our business case. Now we're going to talk about our optimal routing algorithm. So this is sort of how we take that model and implement it in our Python code. First, we create a distance matrix using real-time travel data between all points, pair drivers and packages if they meet our criteria of 20 minutes, limit each driver to 2 packages, allocate unassigned packages, and then export that to our automated pipeline in Google Sheets. So this graphic kind of displays how that algorithm works. We have our commute start in the red and our commute end, the 2 circles. Then we have rings around them, which are an approximation of how far away a package pickup or drop off can be in minutes, not distance, minutes from a start or an end. So we see here, we have the 2 triangles, the red and the blue. These are feasible. They fit within our range. They fit within our time constraint. However, if you see the red square, that's assignable. So it meets the initial range, but it does not meet the secondary range. So we cannot assign that package. Now I talk a little bit about technology. So we really feel, our group really feels that industrial engineering is about using the tools we're familiar with and know best to accomplish a goal and make a process work. So first we started off with Google Sheets, Google Sites, and Google Forms to create our user interface and input our data. Then we used Python with Google Maps API and the Google Sheet API to manipulate that data and implement our algorithm. And then we used Google Sheets and Gmail to take that data back and then send out our confirmation system and notifications to our drivers and our package senders. So Maria's going to elaborate a little more on that confirmation system now.
So the confirmation system works by once the driver gets an email, we created a login system that then triggers a notification system for both the drivers and the shippers with the full details of the routes. We can see more of this in our demo. So here is our website. Our person is currently registering to become a driver. They go to our website and they find the page where you can sign up. They fill out the form with all their information, such as a car or their car, as well as their routes. And then they get an email notification welcoming them to the Delivery Mate team, as seen here. And then a similar thing would happen if someone's trying to send a package. So they go to our website and they find the form, as well as they fill out all their information about the pickup and the drop off. And once that is sent and it's paired with the driver gets an email that contains a order number and some details about the route. And they go to our website and they confirm the order. And here they put in their email, password, and the order number. And once that's verified, they get an email confirming the order with the full details. And so does the person who is shipping the package. It also has some safety aspects like the driver's name, as well as car make and model.
We are able to verify our algorithm through a cycle. It begins with users submitting a delivery request form, which is then matched to at least one potential driver. Drivers are notified of the availability, and if a driver accepts the package, we follow up with a route confirmation email, which provides all of the details regarding a package. To close the loop, drivers submit a photo of the completed delivery to indicate the completion of the cycle. This is repetitive, and each time a cycle is completed, we are able to validate our platform. Project management was broken into 4 categories, and each member took lead on a different part of the project, but we all contributed to each piece. We planned the project holistically to ensure its seamless integration and regularly worked with each other to ensure that we meet our planned checkpoints. However, we did face some challenges and we viewed them as business obstacles. We wanted to ensure potential drivers had flexibility and potential shippers knew their packages were delivered safely. We also dedicated a lot of time to developing an efficient algorithm and a research-backed business model.